So we're here at the example table, and in this video we're going to find a limit by definition. So let's just remind ourselves of what a limit is. So the limit as x approaches a of f of x equals L means that for any epsilon greater than 0, there is a delta greater than 0 such that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is between 0 and delta. Strictly between 0 and delta. Because remember, when we're dealing with limits, we don't care about the value of f at a. So we require that x minus a be greater than 0. So what does this look like in a picture? If we have a curve like this and we're looking for the limit of this function, let's say this is f of x, and we're looking for the limit as we approach a, then we take some little neighborhood around our candidate for a limit L, some small neighborhood, right? Epsilon is small. And then we kind of trace back like this to get a small neighborhood around A. And that's some delta neighborhood around A, a little interval of length. Well, it's delta on either side, so it's going to be length 2 delta. But this is the picture. So let's do an example. So let's verify that the limit as x approaches 3 of 4x squared minus 36 all over x minus 3 equals 24. So we'll start by supposing that epsilon is greater than 0. So suppose that epsilon is greater than 0. Now, one of the things that you'll deal with almost every time you do a limit by definition problem is that you actually work backwards. So we start with an epsilon and then we find a delta. The actual solution that we want is going to start with that delta and work towards epsilon. But we'll start now with epsilon. So we want 4x squared minus 36 all over x minus 3 to differ, right, the expression of our function, to differ from our limit candidate, which is 24, by less than epsilon. So we'll start with this and work backwards to see what our candidate for delta is. So let's rewrite this thing in here. 4x squared minus 36, we can factor a 4 out, and we get 4 times x squared minus 9 all over x minus 3 minus 24. And this we can factor, this x squared minus 9, into x plus 3 and x minus 3. So 4 times x plus 3 times x minus 3 all over x minus 3 minus 24. That's an absolute value. Now, the x minus 3's cancel. They become 1. And so we're left with 4 times x plus 3 minus 24. So let's simplify this with this 24 here in our last step. So carrying over from the last page, we get the absolute value of 4x plus 12. We multiply 4 times x plus 3 minus 24, and this is 4x minus 12. So we can factor a 4 out, and we're left with 4 times the absolute value of x minus 3. And remember, this is the thing that we want to be less than epsilon. we want this less than epsilon. Let's divide both sides by 3, divide both sides by 4, and we get x minus 3, absolute value, is less than epsilon over 4. This is the form that we want to find delta, right? We want x minus 3 to be less than delta. So epsilon over 4 is our candidate for delta. So, as long as the absolute value of x minus 3 is greater than 0 and less than epsilon over 4, we know that 4x squared minus 36 over x minus 3 minus 24 is less than epsilon, since all of the steps that we just did are reversible. And since they're reversible, we can start with delta being epsilon over 4 and then work our way backwards to this expression, which, if you remember, was the one we started with. And that's how you find the limit by definition.